All right, so here's a little computer program I wrote that this morning when I saw we were going to be working on this. So what I'm doing is I'm just seeing how long it takes. So this is just one iteration right now, which doesn't make any sense, but I don't want to give any of the answers away. I don't know why I named the things I named, but averages is just how long it took. Initially I set that all as a table of zeros, and I run a for loop from 1 to the number of trials I'm going to do. And I start out having a table of all zeros from 0 to 5, 5 zeros. And then I run a maximum of 1,000 times because I want it to be way above, I wanted to be sure we got it. And I just pick a random integer from 1 to 5, and I fill in that. If I get like a 4, I fill in the fourth one, say 4. And then I just check if my sum is 15 in my table that starts off being all zeros. Because as soon as it adds up to 15, what does that mean?
You've got every single one.
I've got every single one.
Well, could you add it up to 15 without getting 1, 2, 3, 4, 5?
Well, what I'm doing is I'm starting out with all zeros, and as soon as I get a number, I put that number in that position. So as soon as I get a 3, I change the third position from a 0 to a 3.
So you can't put 2 5s in the table.
Right. If I put a 5 in the table and then I roll a 5 again on my 5-sided dice, I just say the fifth one is now equal to 5, but it was already equal to 5.
Yeah.
So that was just my simple way of saying, hey, if once the total gets to 15, I say it took us this many trials. So if it took 10 trials, averages for this one would be 10, and then I set I to equal to 1,000 to stop my loop.
Yeah.
And then what I'm going to do is I'm going to plot the averages. I'm going to list plot however many times it took. I'll print out what the average of the number of trials it took. I don't know why I called it averages. I'll tell you what the maximum one is, and then I'll make a sort of a probability distribution so you can see what it looked like. Okay. So let's do it 100 times just to get a sense for how this is going to work. There's the graphs of the number of times how long it took. So what do you notice on this graph?
Well, there's one very far outlier that
35.
I just saw around 35.
Okay, does that surprise you?
Yeah.
Yeah, I mean, our expected value was around 10.
11.
11.
So
a little less than 11 and a half.
Yeah, it was 11 and 5/12.
about here, it seems like.
Seems like more of our data seems to be below
But there
than
are.
above, but it is more concentrated below, so it could be misleading.
So I think the data that is above 11 and 5/12, I think it's more spread out, so that probably makes up for it.
Okay, so here it took 10.96 on average, which is near what we thought. 34 was the maximum. And then here's, when I throw them into buckets, here's roughly what the probability distribution is. No trials took less than 5 times.
I can't take less than 5.
Okay. And then here's how things got distributed. You can see we got nothing from 25 trials up to 33 trials, and then we got 1 at 34. What do you think is going to happen if I run it 1,000 times?
There'll be some very far outliers.
Okay, now what do you think the maximum will be?
Maybe like 100.
Okay, what do you think?
I think around 50.
Around 50? Okay, let's run it. Goes pretty quick.
Oh, there's not even 1 at 34 again.
Well, it looks like it says we had 1 at 36.
Oh.
So
it's not growing by too much.
there we go. What do you think? How do you think this probability distribution looks now?
It almost looks like 1/2 of a normal distribution.
Because you can't get the other half. It's almost.
Nice, and you can see our average was about 11.25 this time.
Yeah, close to what we
And
think.
the max was 36 when we ran it 1,000 trials. So that just tells us the max we got the first time around was kind of surprisingly high for only 100 trials. All right, but now what I'm going to do is I'm going to do 100,000 trials. So what do you think the max is going to be here now?
Maybe 50, 45, something like that.
Not much higher.
All right, give me a number.
45.
Okay. So 100,000 trials probably shouldn't take too long. Oh, I saw it flash on the screen. I think. What's happening? Okay.
So 67 is our highest.
So now I get this nice graph, 11.38. And by the way, let's just see what n of, what was it, 11 and 5 twelfths was.
It's matched
11.41. So we're getting pretty
to-
close. It's a good sign that we're getting near. And then here's what our did it not? Oh, there's the plot. Okay. So nice and smooth now. But we did get 65 here was the most it took.
Mhm.
And then let's just for fun, I'll let it run 1,000,000 times, and then we can talk about it. So what did you find interesting about this problem?
I think it was interesting to like see. Like I didn't really know how to do the infinite series that we did. It was pretty neat to figure out how to solve that.
Yeah, it turned out it had a really simple answer,
Yeah.
right? If you advanced X% of the time, what was your expected time to advance?
The reciprocal of that.
Yeah, 1 over X.
It's a simple problem. It's like just basically saying you roll an n-sided dice. How many times do you have to roll it until you get all n numbers?
Yeah, right, exactly. Have you ever been in a situation where you're trying to collect all of something?
Yeah.
What is that situation?
Maybe like this like series of toys that you get randomly.
Okay. Yeah, there's actually a game you play where you get things in packs.
But not magic.
Magic, yeah. You get things in packs. So you might say, hey, whoa, there's 100 cards I got to get here, and what do you get in a pack? 7?
15.
15?
They're-
So it's a more complicated version of this problem, but it's still the same as this problem, kind of. So here's what we got here.
So something is like this, like some grocery stores have promotions, or if you get everything, you like win free groceries or something.
Oh yeah, like that Monopoly game.
Yeah.
And then some of them are skewed to have much lower probabilities, so you won't get all of them.
Right. So then you change each probability of getting something, so it becomes a little bit more complicated. But it's still the same kind of path
Yeah.
that you guys drew. And here we got for the 1,000,000 trials, we got 11.419, and which
So
seems pretty
little.
close. 72 was the longest that it took.
To the max doesn't go up by very much each time.
No, because the max requires you to not roll a specific number
For a
really long time. So that goes, the chance of not rolling a number is what, 4/5?
Yeah, so this is already like insanely low.
Yeah, 4/5 to the 72nd power is insanely low. So imagine taking a 5-sided dice, or even a 6-sided dice, by the way, and rolling it 72 times and never seeing a 6. That'd be pretty crazy, right?
Yeah.
So
It really is like 1 in a million.
maybe even more. All right, cool. Good job, guys. This is a fun project.